Okay, so here we go with this one. Part A asked me to find dy dx, find y prime. I'm going to use y prime notation here. I want to point out that this spot right here is something that trips people up a lot. People wind up not getting their signs correct on the second term. What I've done here is I've written in blue a minus x and in red a minus y. And the reason I'm doing that is because it helps me see that that minus x is going to be my first term in product rule, and the y is going to be my second term. So if I do that, if I recognize that the first term has the negative on it, then I'm less likely to mess it up. So the derivative of the first term is 2y times y prime. That is power rule on the squared, and then chain rule on the y brings the y prime out front. Now, the derivative of minus x, so I'm going to do product rule, derivative of the first times the second plus derivative of the second times the first. So the derivative of negative x is negative 1 times the second is y, and then I'm going to get plus the derivative of the second, which is y prime. Remember, I'm using y prime interchangeably with dy dx. And then times the second, so times negative x. Notice if I do that, you should see that this negative is going to be, it's going to move out there. I'm going to have a negative on both of these terms. From there, it is minus 3 and then equal to 0. So I will rewrite it. I get 2y times y prime minus y minus xy prime. I like to reorder it like that. Minus 3 equals 0. So from there, I'm going to take the 3 and the y and move them over. 3 plus y, they're going to change signs. So that's gone, that's gone. And now I'm going to write y prime and open and close a set of parentheses. And then I always like to fill in here what would be equivalent to this term and that term. So I'm going to get a 2y and then a minus x. From there I get y prime is 3 plus y over 2y minus x. Okay, now for part B, I want the equation of the tangent line at that point. So I go y minus y1 equals m times x minus x1. That is my y1. This is my x1. So I get y plus 1 equals, I'm going to leave the m blank for now, x minus 1. So here I'm going to do this at 1 comma negative 1, and that gives me the y prime of 1 negative 1 is equal to, I get 3 minus 1 over 2 times negative 1, and then minus 1, which comes out to be 2 over 3, but negative. So that gives me negative 2/3. So I get y plus 1 equals negative 2/3, open parentheses, x minus 1. That is the answer for part B. Okay, so the last part asks for vertical tangent line. So you should know that if I've got a line like this, a straight line, the slope is delta y over delta x. Well, if I think of a vertical tangent, notice delta x, no matter how much y changes, x does not change. So if I think of y prime as dy dx, then I need that spot to be 0. So anytime I have a derivative in a fraction form like this, I can just set the bottom to be equal to 0, and that's going to give me a vertical slope. So I'm going to set that equal to 0, That gives me 2y minus x equals 0. From there, it's like you may say to yourself, well, what do I do here, right? Well, we know that this relationship has to be true between x and y. We also know that it's on this curve, so that relationship there has to be true. So in one way or another, I need to get rid of one of the variables and kind of solve for the one that I have left, and then figure out what the other one is. So in this case, the easier way to do it is to solve for one of these two and then plug it into there. And if I do that, then I'm only going to have one variable in this thing, well, the other form of it. Hopefully I can solve, and then I can come back and reuse this to get the other one. So if I move the x over, I get 2y is the same as x. And then what I can do is take this guy up here, but change that to a 2y and that to a 2y. So I'm going to get y squared minus 2y times y, and then minus 3 times 2y, and then that's equal to 5. So notice this x is that 2y, because x and 2y are the same thing, and then same thing with this, replace that. So from here, I've got y squared minus 2y squared minus 6y is equal to 5. Here I notice, oh, it's a quadratic. So I want to get everything onto one side. Maybe I will, actually I'm going to leave everything on one side at first. When I do y squared minus 2y squared, I get negative y squared minus 6y is equal to 5. The reason why I simplified that first is because now I recognize, oh, I don't like it when quadratics have negative coefficients in the front, so I'm going to take these two terms and move them over there. So that gives me 0 equals y squared plus 6y plus 5. From there I factor y and y. I need things that multiply to 5, that add to 6. Everything's positive all the way through, so it's plus 5 and plus 1. From there, I know that y is negative 5, or y could be negative 1. Now be careful, if I go back up here, I want all points, right? This is the y coordinates for which that's true. You need to get the x coordinates that go with each of those. You may say to yourself, man, do I have to do that all over again and like plug things into here, up here? And the answer is no, because remember I used this, right? So if I know y is negative 5, then I can get x, the x that goes with that, by plugging in negative 5 there, right? So notice if I make this in there, I get x is negative 10. So that gives me one coordinate is negative 10, along with a negative 5. And then I can do the same thing with the negative 1. Well, if x is negative, or if y is negative 1, then negative 2 times y, which is x, well, that's negative 2. So I get negative 10, negative 5, and negative 2, negative 1. And that is my final answer.